7th graders, let's give our last lesson in 410 a try. It is I can solve problems involving scale, drawings, and models. This is lesson 410, starting on page 236 in your textbook. So beginning, we have, notice this is a statue of Abe Lincoln here, the Lincoln Memorial. So the statue of, in the Lincoln Memorial is shown to the right. How many inches tall is the photo of the statue? The actual height of the statue is 19 feet. So we're going to write a ratio comparing. This is just to give an example of how would we find out. Obviously, this picture is smaller than the actual monument itself. So this is kind of giving you an idea of what we do. So if you had a ruler, you could go ahead and measure this photo. And the photo, if you measured, would be 2 inches high. And then if we know the actual is 19 feet, then that the ratio would be comparing that's 2 inches to the 19 feet of the actual, and then simplifying that ratio, that there'd be 1 inch is equal to 9.5 feet in reality. So it's just an example to get you warming up, thinking about scale models and scale drawings. Obviously, a photograph is a smaller version of what you're actually taking a picture of. So a scale drawing or scale model is used to represent an object that is too large or too small to be drawn or built at actual size. And we talked about that a little bit with indirect measure, about how sometimes you're not just going to measure things. You're going to get up on a ladder and measure your house. So the scale is the ratio of a length on a drawing or model to its actual length. If you were really into Legos, or something like that. Obviously, you can build a Lego model to look pretty similar to like a helicopter or something, but it's not actually the size of a helicopter. So that would be like an example of a model of what a helicopter really looks like in real life, or what architectures do, and they do drawings to make the floor plans for houses and things like that. So an example would be 1 inch equals 4 feet. That's just 1 inch is representing an actual distance of 4 feet. So if you were going to make a model of something and have a smaller version like doll houses, things are pretty proportional. This is an example of how you use those. 1 to 30, that would be 1 unit, represents actual distance of 30 units when there's no units attached. So let's get started with an example 1, and this is in your textbook. So use the map to find the actual distance between Grenada, Mississippi, and Little Rock, Arkansas. The distance on the map is about 5 2/10 centimeters. Okay, so they're asking for us to find the actual distance from where? From here, Grenada, and Little Rock, Arkansas, here to here. And they're telling us that that is about 5 2/10 centimeters. So you're going to use, you're going to set up a proportion. So I'm going to compare the scale and distance. And what you want to compare is your map to the actual distance. So I know that 1 centimeter on the scale here on the map is equivalent to about 50 kilometers in actuality. And what we're wondering is on this map that we're viewing, it's 5 2 centimeters, and we're wondering how many kilometers that is in real life. So you set up that proportion, again comparing what you know and what you want to find. So if you solve that proportion, you're going to end up with multiplying across. So we end up with 1x is equal to 5 2/10 times 50 is then 260. And obviously that's just dividing by 1, which is 1. So x is equal to 260, and in this case, kilometers. So Grenada to Little Rock, Arkansas is 260 kilometers away. What if we're asked to find the scale? So here's a situation, a real world link up at the left there. Scientists estimate that Tyrannosaurus rex was 400 feet long and 18 feet high and weighed 6 tons. Holy buckets. Scales, and there's a study tip here on the bottom. Scales and scale factors are always written so that the drawing of model length comes first in the ratio. So the model comes first in this case. Okay, so that's one thing, good thing to know. so we don't mix up our writing of what goes first. So one of the models of a dinosaur used in the filming of a movie was only 15 inches tall. In the movie, the dinosaur appeared to have an actual height of 20 feet. What was the scale model? And we're going to let X represent the actual height of the dinosaur in feet. So again, we're going to do length and scale, and we're going to compare the model to the actual. Okay, model to the actual size of the dinosaur. My smartboard's being a little weird, so bear with me. So the model dinosaur was 15 inches when the actual was supposed to appear 20 feet. So we're going to set that equal to what we know. Well, what would 1 inch be equal to in terms of feet then? Well, how many feet were we trying to get 1 inch to represent? So you do your cross products of 15x is equal to 20. And then so we divide by 15 to get x alone. And we find out that x is equal to 1 and 5/15ths, or rather, we simplify that to 1 and 1/3. So what this means is that the scale that we're looking for, because we're looking for the scale model, is that 1 inch is representing 1 and 1/3 of a foot. Okay? So 1 inch is equal to 1 and 1/3 of a foot. Finding the scale factor is another part of this. So the question, expanding on this dinosaur question, and there's a study tip on the left, and we're now 238 in your textbook. A scale factor between 0 and 1 means that the model is smaller than the actual object, and the scale factor greater than 1 means the actual model is larger. The model is larger than the actual object. And we talked about that a lot when we did the dilations one. We talked about scale factor there. It makes something less than 1, obviously you're shrinking it down. Something more than 1, obviously you're expanding it or enlarging it. So an example, obviously dinosaurs you'd make smaller with a scale factor, whereas like maybe if you're looking at atoms and trying to build a model of an atom, which is the smallest thing, you'd obviously enlarge that so that it was visible. So for example 3, if we were to find the scale factor for the dinosaur from example 2, you would convert to inches by multiplying by 12, because we know that there's 12 inches in 1 foot. So what we did there was multiply by 12 to find out how many inches it's worth. So that means the scale factor is 1 to 16, or 1 to 16. You remember using the fraction or using the colon. So this means that the dinosaur model is 1/16 the size of the dinosaur's appearance in the movie. Okay, and there's some on the bottom there that you can give a try as well. And you do have to know, for D, you have to know how many centimeters are in a meter, and so on and so forth. So you can give those ones a try, and we can revisit C and D when you come to school. So reread, look in your book, try to work out some of those examples. Practice maybe looking at a map, looking in an atlas, doing some real world examples, and we will see you when you return with some good notes and some good questions.